This problem can be long or it can be short. It depends on how you go about it. So I'm going to try to show you the short version and explain to you what will happen if you do it the long way around. First things first, we got to get it up on the board. X over x minus 3. So in the previous problem, what we did is we took the denominator down here and we just went up, okay, and rewrote it right up over here. And then we took this denominator and we brought it diagonally up and wrote it up here. It's the fastest way to go about this problem. However, I wouldn't suggest doing that just yet. Let's remove some of these lines. Okay. What I would do is I'd take a look at this problem first. And I'd do some factoring out. For example, notice over here we have a 10x and then a 30. So we can pull a 10 out of there. Yes, we can. And we're going to rewrite this problem. And we're going to do just that. So if I had 9x plus 3 over 10x minus 30, I'm going to factor that 10x out. Or I'm going to factor the 10 out, that's what I meant to say. So now we're left with x minus 3. So you can always multiply that 10 back across inside, and you'd have 10x minus 30 is equal to x over x minus 3. Now what you can do is multiply both sides by x minus 3. What's going to happen? These guys are going to cancel out when you do that if you multiply both sides by x minus 3. So that is what we're going to do. So we'll just say we did it. How's that? And when we do that, we're going to be left with 9x plus 3 over, hey, how about we just move this 10 right up over here? Just move it, multiply both sides by 10. Let's do that. Okay, let's do that also. So that's going to make that a 10x. Okay, so the x minus 3 is canceled out on both sides because we multiplied both sides by x minus 3. We say we did it. Now look what we're left with. Now I'm going to tell you, if you didn't do that, take that route and did what I said in the very beginning and then multiplied all that stuff out, collect up like terms, then you got a factor, forget about it. Okay, do it just like this. We have a positive 10x and we have a 9x here. So I'm going to leave the 10x over on the right and just bring the 9x over, so that becomes negative 9x. That's why we're not dealing with negative coefficients. And then we're left with x is equal to 3. Boom. Okay? Pretty simple. X is equal to 3. Now this is a possible solution here. Now remember what I said. It's a possible solution. Okay, x is equal to 3. Now let's go back up here. If I plug 3 into this denominator down here, well, if we plug 3 in, let's just do it. You'd have 3, let's just do it like this. You have 3 over 3 minus 3, which is actually 3 over 0. Okay, 3 over 0 is not a number. See this? Undefined. And so 3 can't be a solution to this equation. Even over here on the left-hand side, we get the same thing. 10 times 3 is 30, and 30 minus 30 is 0. Okay, 0. So 3 is not a solution, even though we got down to the final And we said, yay, 3. No, sorry. But I got to tell you, no solution. Okay, or you could write empty curly brackets. The empty set doesn't contain any solutions. Alright, so that pretty much ends this. There we go. I think that was our first equation, where we tried to find the solution and we came up with no solution. There was no solution. Alright, I'll see you in the next problem.